Lava flows are one of the coolest, or maybe hottest, features about volcanoes. But what would a lava flow look like if you were able to peel away the surface and take a peek underneath? I'm standing here at Sheep Eater Cliff in Yellowstone National Park, just north of Yellowstone caldera. It's a great example of columnar joining in a basaltic lava flow. The composition is very similar to the kinds of lava flows that we see in Hawaii, and it's named for a band of the Shoshone tribe that lived in the area year-round and subsisted off of bighorn sheep. These spectacular columns actually tell us quite a bit about the conditions that this lava flow formed, and we see the same kinds of columns in lava flows and ash flows around the world. Let's go have a closer look and talk about those conditions and what we can learn from this really spectacular rock formation. Well, the first thing we can learn from these columns is that this lava flow cooled very slowly, and when it cools slowly, it contracts. The contraction forms these sorts of columns, which have a vaguely hexagonal shape when you view them from above. The other thing we learn from these sorts of columns is that the cooling surface in this case was horizontal, because the cooling surface is always perpendicular to the direction of the columns. In some places you can actually see horizontal columns where a lava flow or ash flow cooled against a canyon wall or maybe even the side of a glacier. These columnar joints are very, very common. Here in Yellowstone we see them over by Tower Junction in the walls of the Yellowstone River Canyon in a couple of 2-million-year-old lava flows. Obsidian Cliff, which was a hugely important site for the indigenous people of the region for thousands of years, has beautiful columns. Devil's Tower, Wyoming, Devil's Postpile in California, in the Columbia River Gorge of Oregon and Washington. Even internationally, the Giant's Causeway in Ireland, many places in Italy. Iceland, there's a place where columnar joints actually form the floor of a church because the hexagonal pattern actually resembles a tile floor. So we learn a lot from this sort of pattern. It tells us something about the cooling history of the flow, and it also tells us something about the cooling surface that the flow was up against. Well, that's the story here from Sheep Eater Cliff. Now let's talk about seismic deformation and geyser activity that occurred around Yellowstone during the month of October. It was another pretty average month in terms of earthquake activity in the Yellowstone region. During October, the University of Utah located 113 seismic events. The largest was a magnitude 3.3 in the early morning hours of October 10th on the east side of the park. There was also a swarm of 42 earthquakes that occurred near Norris Geyser Basin. That occurred in early October, and the largest event of the sequence was a magnitude 2.4. And this was part of this belt of seismicity that extends from Hebgen Lake into the north-central part of the park near Norris. This is where most of the seismicity occurs in the region. So pretty average month for earthquakes in Yellowstone. Looking now at ground deformation, this is vertical deformation of the caldera, the White Lake GPS station. Each one of these blue dots is 1 day's worth of data, and the entire time span we're showing here is 2 years. And we're seeing the same trends we've seen since 2015. Overall subsidence by a few centimeters per year, maybe an inch or two, and that's interrupted in the summer months by a little bit of uplift, a fraction of an inch, maybe just a centimeter, maybe two. And that's caused by runoff from snowmelt and rainwater that percolates into the ground and causes the ground to puff up like a wet sponge. Once the summer is over, we see continued subsidence, and there's the uplift from 2022, and here it is again in the summer of 2023. And in October, we were just starting to roll back into the normal subsidence when we see sort of a dramatic subsidence here right at the end of the month. That's not a real signal. That's a sign that winter has arrived in Yellowstone. A recent snowstorm dropped quite a lot of snow, and that's covered the GPS antenna, and it creates this artifact. You can see other examples of that during other winters as well. So winter certainly has arrived in the Yellowstone region. Now finally, looking at the tallest geyser in the world, Steamboat Geyser. This is the temperature record in the geyser's outflow channel. Lots of up and down activity in the beginning of the month is a sign of minor eruptive activity, and that culminated with a major water eruption, the 7th one of 2023, on October 8th. And after that, activity dropped back down, and we just saw daily temperature variations. That's a sign that the geyser was really not erupting during this late and mid part of October. And then it got very cold, and again, because winter has arrived in Yellowstone. So we're not seeing any minor activity of Steamboat Geyser right now. We would expect to see an increase in minors like we saw at the beginning of October before any future major eruption. So that's something to keep your eye on as to whether or not Steamboat is going to erupt again before the end of the year. Look for this minor activity on the temperature gauges. Well, that does it for the November 2023 YVO update. Please like and subscribe. And remember, if you have any questions at all, don't hesitate to email us. Our address is yvowebteam, all one word, @usgs.gov. Stay safe, stay healthy, and we will see you next month. Bye-bye.